Alright, boys and girls, we're just going to quickly look at the binomial theorem today. Okay, so we've got our binomial a plus b to the power of n. Let's expand that out. Now, in the back of the book it states this. We've got n choose r, a to the power of n take r, b to the power of r. Where does this actually come from? Well, let's have a look at this expanded out. Okay, let's say we've got a plus b to the power of 3 or something like that. The first term, okay, we've got n choose 0, a to the power of n take 0, b to the power of 0. What does that become? Well, that's simply a to the power of n, isn't it? Okay, so let's say this is a power of 3, that's just a to the power of 3. If I do that over here, a plus b to the 3, okay, we've got a to the 3 is our first term. We know that, okay, plus the next term should be 3a squared b plus 3ab squared plus b to the power of 3. Okay, so that there is a to the power of n. If we had choose n1, a to the power of n take 1, b to the power of 1. Alright, if this was a 3, that would be a to the power of 2, b to the power of 1. A to the power of 2, b to the power of 1. That works. Alright. C, n to the power of 2, a to the power of 2, n take 2, b to the power of 2. Okay, let's have a look at this. If that was to the power of 3, that would be a to the power of 1, which is correct, b to the power of 2, correct. So r can be any value. R is going to equal any value, 1, 2, 3, etc., all the way until it reaches n. Okay, because once it reaches n, it doesn't make sense to have, let's say, 5 choose 8. Okay, so that must be 5 choose 5 would be our last term in the expansion. Now let's have an example of one. Okay, let's go 2x take 3 to the power of 3. Just a random value. Alright, if I'm to use this binomial theorem to expand this out, we've got the first term would be choosing n, which is of course 3. Okay, and r would be 0. That's our very first term, 0. So we've got a, which is 2x. 2x to the power of what? N. N take 3. 3 take 0 is just 3, isn't it? Okay, and this b, minus 3, to the power of 0. Alright, as stated in our equation right here. Then we've got to add. The next term would be, we're choosing 3 still. 3 choose 1. Alright, and we've got 2x to the power of, sorry, I'll put that to the power of as well. 3 take 1. Okay, and b, which is our minus 3, to the power of 1. The next one, c to the power of 3 choose 2 would be 2x to the power of 3 take 2. Alright, and minus 3 to the power of 2. Minus 3 to the power of 2. And our last term is 3 choose 3, okay, which is of course 2x to the 3 take 3, which is 0. Add minus 3, sorry, I'm running out of space here, minus 3 to the power of 3. Alright, so let's do all of this. What does this even mean? Oh, well, once I expand it out, it's pretty simple. 2x to the power of 3, okay, this is 1, so anything times 1 is itself, so 2x to the 3 is what? 2 to the power of 3 is 8, x to the 3. That's our first term. Add our next term, 2x to the 3 take 1. Well, 3 take 1 is 2. What's 2x squared? 2 times 2 is 4. X squared. Alright, and I'm going to times that by minus 3. So once I've got this, okay, I've got to multiply by that 3 choose 1. If you do 3 choose 1 in your calculator, you'll just find that becomes 3. Add all of this. 2x to the 1 is of course just 2x. Okay, multiplied by minus 3 squared, which is plus 9. So multiplied by 9. Okay, and we've got to times that by 3 choose 2. And I think 3 choose 2 you'll find is 3 as well. Add 3 choose 3, which is 1. Okay, 2x to the 3 take 3 is 0. So that's just a 1. times by 3 to the power of 3, that should be minus 27. Okay, once we expand all of this ugly mess out, we'll find that we get minus 12 times 3 would be minus 36x squared. Add, that's 18 times 3, 54x. And that, of course, is just take 27. Alright, so I've got a bit of an ugly mess, but I've come to the expansion using my binomial theorem there. Alright, if you're stuck with this, please let me know. I can see how this got a little bit confusing, but as long as you're using this n choose r, you'll be able to get the correct answer in the end.